Can you find the number of neutrons in this ion? Using a mass spectrometer, a calcium 2+ ion is found to have a specific charge of 4.56 times 10 to the 6th coulombs per kilogram. The researchers want to find out how many neutrons this isotope of calcium has. What you should already know. The specific charge is the charge per unit mass of a particle. It's given by the equation specific charge equals charge of the particle divided by the mass of the particle. A calcium atom has 20 protons. The mass of a proton or neutron is 1.67 times 10 to the minus 27 kilograms. The mass of an electron is 9.11 times 10 to the minus 31 kilograms. The elementary charge is 1.60 times 10 to the minus 19 coulombs. And the relative charge of a proton is +1 and an electron is -1. Pause the video now to solve for yourself. The first thing to consider is the fact that we have an ion. As it's a 2+ ion, that means it must have lost 2 electrons. This leaves 20 protons but only 18 electrons. So we need to set up the problem by finding Q and M. The total charge is going to be the charge of the protons plus the charge of all the electrons. There are 20 protons, which each have a positive charge. We add this to the 18 electrons, which each have a negative charge, and we multiply this number by the elementary charge 1.60 times 10 to the minus 19. This gives us a charge of +2 times 1.60 times 10 to the minus 19 coulombs. The mass is a little more difficult. We have to consider the mass of the protons plus the mass of the neutrons plus the mass of the electrons. We already know there are 20 protons, but we don't know the number of neutrons, so we'll denote this with an n. So we've got the mass is 20 plus n. We multiply this by the mass of the proton and the neutron, which is 1.67 times 10 to the minus 27 kilograms. Then we add in the 18 electrons, which each have a mass of 9.11 times 10 to the minus 31 kilograms. Placing this into our equation, including the specific charge that we were given in the question, we get the following formula. Evaluating this to make it a little simpler for us, we get 3.20 times 10 to the minus 19 on top, and we can simplify the 18 times 9.11 times 10 to the minus 31. Next, we'll move what's underneath the division line to the left side of the equation. Meanwhile, what was on the left side of the equation will move to the right. Simplifying this, we then end up with 20 plus n times 1.67 times 10 to the minus 27 kilograms equals 7.02 times 10 to the minus 26 minus 163.98 times 10 to the minus 31. Finally, this gives us 7.02 times 10 to the minus 26 divided by 1.67 times 10 to the minus 27. This gives us 42.011 and n as 22.011. Since we know that you can't have a fraction of a neutron, therefore the number of neutrons in this isotope is 22. Try solving the following for yourself. The answers will be given in the link to the description below.